Dear colleagues, I would like to present my report, Consciousness Model, Providing Maximum Accuracy of Reality Prediction. We will base on the following approach to the brain-mind problem by David Israelovich Dubrovsky. Consciousness has a specific and inherent quality of subjective reality. The problem of consciousness and the brain can be considered as the problem of subjective reality in the brain. But this consideration requires a conceptual system linking the phenomena of subjective reality with the brain process. And this conceptual system based on the following points. First, the information is embedded in its physical medium. Second, information is invariant relative to its physical carrier. Third, subjective reality can be considered as information related to the corresponding brain process as its carrier. Based on this information approach, we postulate the following principles of the information theory of consciousness. First, this information theory must be the theory of anticipation of the outworld. But if outworld were random, the anticipation of it would be impossible. But our world is well structured, and the structures need to be used. The information theory of reality reflection should be based on the loss of outward information structure, and simultaneously describe both the information structure of reality and neurophysiological and other mechanisms that ensure the reflection of this structure. Based on these principles, we developed consciousness model that based on only one principle. Brain discover all possible causal relationships in the outworld and draw all possible conclusions from them. This principle based on the formal model of causality of the outworld. Also, we developed a formal model of neuron, model of purposeful behavior, consciousness model, and as a result, we argue that developed models ensure the maximum accuracy of the reality prediction. The first information law of the outworld is its causality. In the philosophy of science, causality is reduced to prediction and explanation, and causal relation reduced to the inference of predictions from the available facts and laws. There are two types of prediction: deductive nomological, based on facts and deterministic laws, and inductive statistical, based on facts and probabilistic laws. But inductive statistical inference faced with the problem of statistical ambiguity. Here is a classical example of this problem. We can formulate two rules, and we can have three facts where J. Jones received a streptococcus infection, from which we can infer that J. Jones cure and also that J. Jones not cure. To receive this problem, Karl Kempel suggested the requirement of maximal specificity, which informally means that we need to use all possible information in our rules. But unfortunately, the problem of statistical ambiguity was not solved. In our work, we formulate a requirement of maximal specificity so that we can prove that inductive statistical inference that use these maximal specific rules is consistent. To infer rules that satisfy the requirement of maximal specificity, we can use semantic probabilistic inference. This is a sequence of rules, C1, C2, and so on, Cn, which predict some fact G, such that each next rule have a strictly more conditional probability. We can prove the following theorem. A rule satisfies the requirement of maximal specificity if it is a leaf of the semantic probabilistic inference and have a maximal value of the conditional probability. A rule satisfying the requirement of maximal specificity we will call a maximal specific causal relation. Also, we can prove a theorem that inductive statistical inference based on maximal specific rules is consistent. The semantic probabilistic inference may be realized as a formal model of neuron that satisfy the Hebbian rule. The learning of maximum specific causal relations along the dendrites may be presented as semantic probabilistic inference. It adds to the premise of causal relations all stimulus that increase the conditional probability of the goal feature excitation. It realizes the first level of the ensuring of maximal accuracy of predictions by the maximum specific causal relations. Based on the causality of the outworld, we can formalize the functional system theory of the purposeful behavior, which based on the discovery all possible causal relations between actions and its results. If we have some need, it activates the motivation excitation, which extract from the memory all possible cases which previously lead to the need satisfaction. All these cases go to the decision-making block, where the most appropriate case is extracted, which lead to the need satisfaction with maximum probability. It goes to the next afferent synthesis block, which this case is divided on some steps, and for each step it activated a corresponding action and its result. This is a simple scheme to explain the work on functional system based on the learning of causal relations between actions and their results. In the quote below, there is a result of investigations of the Piotr Kuzmich Anokhin school. When an impulse from the pyramid neuron goes to muscles and some action begin, copies of this impulse go to projection areas of the brain, where connection between the action and its results may be formed by a neuron detecting this result. If we have some need and corresponding motivation excitation indicated by a black triangle, and we want to satisfy this need by a try and error method, we may perform some action indicated by a white triangle. In that case, copies of this excitation will be sent to projection zones, where there will be some neuron indicated by a white triangle that accept the action result and form a causal connection between action and this result. If we then perform some other action to meet the need, then there also will be a neuron that will record a conditional connection between this action and the received result. If, as a result, we have satisfied the need and obtained desired result, the entire chain of actions along with causal relations will be stored in the memory. In that case, the need and motivation excitation arise again, then we will be able to predict from the inner contour of conditional connections that if we will perform these two actions, we will get a result. If we decide to choose this plan of actions for satisfaction the need, then even before any action, we will form an acceptor of action results, which consists in expectation of the first result after the first action and the second result after the second actions, and finally the expectation of the need satisfaction. Thus, by decision and choose the action plan, we also predict the achievement, the goal, and the need satisfaction before any action. And after that, we can decide to realize this plan. In this scheme, the previous simple scheme is presented along with the causal relations that are learned by the functional system. This is the most illustrative example of the functional scheme working. Here is electronic model of nematode, which was learned with the functional system scheme to its natural movement. Now we consider the structure of consciousness based on natural classification and natural concepts as the informational laws of the outward object structure. The taxonomic problem of natural classification is in indication. From a potentially infinite number of features, we need to go to a limited number of indicator features. From that follows the informational law of natural classification. It consists in potentially infinite number of features of natural classes are connected by an exponential number of causal relationships. So natural classification is very informational rich. This fact is confirmed in the cognitive science. By Eleanor Roche was formulated the following principle of categorization of natural concepts. The perceived world is not an unstructured set of equally likely attributes. On the contrary, the material objects of the world are perceived as having a highly correlated structure. The highly correlated structure of attributes also formalized in the theory of causal models by Bob Prechter. In this theory, the relation of an object to a category is based on the similarity of the generative causal mechanism. This property is explained in our principle that the brain makes all possible conclusions about causal relationships. So, reflecting the highly correlated structure of objects of the external world, the detected causal relationships of natural objects loop on themselves in the process of inference, forming a certain resonance of causal relationships, which automatically forms similar ensembles of the simultaneously excited neuron that generate causal models that form prototypes of the object classes. Highly correlated structure is appear in Guglielmo theory of consciousness as an integrated information. What we need to know is how much information is generated by the system as a whole, over and above the information generated independently by its parts. So, integrated information. Integrated information gives us the possibility to extract complexes as a local maximum of integrated information. For developing a formal model of natural concepts, natural classes, and integrated information by Tononi, we developed a probabilistic generation of formal concept analysis, which is the following. The probabilistic generalization of formal concepts was received in the following steps. First, we defined the formal concepts as fixed points of implications. Then we generalize implications to a maximally specific causal relationships that possess the following important properties. Then we generalize a formal concepts as a fixed points of these causal relationships. Then we prove the theorem that these fixed points are consistent. In that case, we can define a natural classification and natural concepts as a fixed points of these causal relationships. From that definition follows that each class can be described by its own set of maximally specific causal relationships. In that case, the prediction of object properties of the class is more accurate as it based on the causal relationships of the class. It provides the second level of ensuring maximum accuracy of predictions. This is the simple example of fixed points of digits. We get the following digits. We get for 30 examples of each digit. Each digit is described by the 24 features with following values. We mixed these digits and discover all causal relationships on them. And for example, we have following relationship. If we have this feature and this feature, then it must be following feature. If we have this feature and not this feature, then it follows that we may predict this feature. If we have this feature, then it follows that we have this feature, and so on. Then we ask the algorithm to find all fixed points of these causal relationships. In that case, algorithm will find all digits and its descriptions. And these descriptions will be described by all causal relationships which loop on themselves by predicting the features of this digit. And it forms the fixed point of this digit. Thank you for your attention.